Okay, so today we're in line of best fit. I'm only going to do one example with you. There's 2 examples in this lesson. We'll do the second example on Monday. And then we'll do 6 point, well, we may end up just sticking with this example. We'll just see how long it takes. We'll knock out 6.3 and 6.4 next week, and then we'll just start reviewing for midterms. So midterms are really going to be more of our focus next week. All right, so today we learned line of fit, or we're learning about line of fit. And what is that? It is a line drawn on a scatter plot. So we learned about scatter plots yesterday. Close to most of the data points. However, it doesn't have to pass through any of the points, actually. Okay? It just needs to pass, or it needs to be close to most of the points. So we'll talk about that in just a sec. All right, so here's our scenario. It says that this table right here shows the number of absences in a school year and the final exam scores for several students. So we need to make a scatter plot of the data, draw the line of fit, and then try to make an equation based on the line of fit. Then we're going to interpret the slope and the y-intercept. So this is like definitely packed with a lot of information here. All right. So, let's start working. All right. The first thing we're going to do is figure out what x values we need to put on our scatter plot. So we see the range of x values here that stands for absences. What do you think you're going to put on your scatter plot? Go by ones. Yeah. Now, go by twos, but skip every other one, okay? That's what I did. I went 0, 2, 4, 6, 8, 10, okay? But notice that I skipped one. What do you think that first one is? It's the odd numbers, right? 1, 3, 5, 7, okay? But that just kind of still gives it that spread out feeling, all right, versus everything scrunched together. All right, so I've got my x values. Did y'all label them? Now we need to talk y values. Do I want to count by ones on my y values? No, right? That would be crazy. And then do I want to start at 10, skip 1, 20, skip 1, 30, skip 1? Please tell me no one's going to have a final exam score down there, right? And they don't, according to the data. So what's going to happen if this is how I set up my scatter plot? What's going to happen to all this space down here? Is there even going to be anything there? No. So you want to be careful of that. Even when you decide, oh, well, I want to go by 5s or 10s, that space just ends up getting wasted. So what I would suggest is start with a 50, right? Just start, below the lowest value. You don't want it to start like right on the bottom. Now skip 1, 60, skip 1, 70, 80, 90, and 100, okay? And what you want to make sure of is, do all these values, is the range large enough to include all your x values and all your y values? Any y values over 100? No. Okay, so I'm good. Now I can start plotting my points. My very first order pair, 0, 97, 3, 88, 2, 93. So this is what we did yesterday. All right, go ahead and get the rest of your points on your scatter plot. All right, so get all the points plotted. Okay, and what we're going to do is we're going to try to draw a line through most of these points. What was that one? Okay, so here's all my points on there. Now, I do know, okay, that if I have a y-intercept, that's a good starting point. Actually, I messed one up. Hold on. Okay, there we go. If I have a y-intercept, the line should pass through that point. Okay, so that's where I like to start the line. All right, I like to start the line right there on the y-intercept if I can. And then I'm just going to draw it as much as I can through as many points as I can. So, for example, that doesn't mean like I would start here and draw it this way. It doesn't pass through any of the points. That would be ridiculous. Or here, I'm trying to get it through as many points as I can. All right, and what your rule says is find 2 points on this graph. All right, and if you look at mine versus the book, mine is really close to the book, but it's not quite right on. All right, and this is where that variation gets to be a little frustrating for me on line of fit, okay? It doesn't mean that it's not possible, though, and even if you're a little off on your slope part of it, that it doesn't mean that you're wrong, okay? Because, again, it's an estimate. So I'm going to try to find 2 points on this line where the line passed right through the 2 points, all right? So obviously this one, okay? Obviously the first one, that should be all of ours. Now I'm going down and I see it really does pass directly through that one too, okay? And it passes directly through this one, I think, too, and this one, all right? So to calculate my slope, I want to use 2 of these ordered pairs. I need to pick 2 ordered pairs where that line passed through the 2 points. That's what your book says. It says try to have as many points above and below the line as possible and find 2 ordered pairs that the line passes through. All right, so that's what we're going to do. The first ordered pair I see is 0, 97. 097. The second ordered pair that I see the line passing through is 388. Now, it just so happens to be the first 2 ordered pairs in the table, okay? If you're really struggling and you're like, I drew this line, but I am just not sure, okay? You can pick 2 ordered pairs from the table, okay? The first 2. And calculate it that way. You might be a little off. In this case, we kind of lucked out on that. All right, now we're going to calculate slope. You can do that, right? y2 minus y1 over x2 minus x1. So y2 is which value? Which value? 88. y1? 97. And x2 minus x1. So what's 88 minus 97? 88 minus 97? -9 over 3. So my slope is -3. Now, do I have all the information I need to write my equation? Yes, I do. Okay, because one of my ordered pairs had something. Had a 0, so the other number is my y-intercept. Just like we learned in chapter 4. There it comes again, right? So y equals -3x plus 97. So everybody see how I got that equation? All right, now, the part for slope, we're going to need to do that a couple more times, okay? I'm not expecting you to turn around right now and be able to calculate slope for line of fit, okay? We're going to need to practice that a few more times so you know how to better estimate that, all right? So don't worry if that's the part that you're getting lost on. But does everybody understand how we got 97? You guys see that part? Sorry. Okay. Does everybody see why we plugged in -3 right there once we found it? If you're interpreting the slope, which number are you looking at? If you're interpreting the slope of this equation, which number are you looking at? -3. So what does -3 mean? -3 tells me how x is affecting y. Okay, so let's give a name for it. What is the name for x? Absences. So -3 tells me how absences are affecting what? Grade. Final exam score. So in this case, and then of course the scores are points, right? The interpretation for the slope can be something like this. That scores will expect. Now this is not a guarantee. It's not like, oh, sorry, you got another absence. Your grade's going to drop now 3 more points. But they're making a prediction that your score will drop 3 points per absence. Okay? Or you could have said for each absence, the score would be expected to drop 3 points. All right, so it doesn't have to be these exact words. But you're showing how the slope is affecting, or the slope is relating x to y. All right, and again, the more we practice this, the more you're really going to get the hang of it. Okay, so that's my slope interpretation. Now let's go to the y-intercept interpretation. You are still relating x to y on your y-intercept. You're still relating x to y. Well, what's your x value in the y-intercept pair? What's your x value? 0, right? Could anybody put that in a sentence for me? Kind of just the same way I did slope, pretty much, Isabel? Could be, would probably be, or you could expect. It's not a guarantee, right? I can't say, well, if I have perfect attendance, or I can't tell you that at the beginning of the semester, hey guys, don't worry, as long as you have perfect attendance, you'll get a 97 on your midterm. Don't you wish it worked like that? You're like, man, I'm going to be in school every day. Now, why do you think, because this is somewhat accurate, right? Why do you think these two have what kind of a relationship? Would this be negative or positive? Why do you think that there's a negative relationship here between x and y? Addison?
Like the more absences you have, the more your score drops.
Right. Like if you're not in school, you think you're going to do well on your test? No. Okay. So just being here, and I mean, that definitely applies to our class, doesn't it? If you're in class and you're doing what we're doing together and you're following along and participating, that should help your score. Okay. So there definitely is some relevance there. All right. How do we do on those interpretations? Do okay? All right. That in a nutshell, that's it. Okay. Now this is on your midterm. It's one question on your midterm. Okay. All right, just the equation part, and it's on your review sheet too. All right, so then basically in example 2, it's the same thing. Let's see, what time is it? I do want to get started on your review sheet too. In example 2, it's pretty much the same thing. It's just a different scenario. This table shows the number of people who attended a festival over an 8-year period of time. All right, so my x values, this is probably pretty simple, right? What am I going to put on my x values for my scatter plot?
Count by ones.
Yeah, count by ones, right? So I just skip every other one, 2, 4, 6, and 8. Okay, and then for my y values, what do I want to go by? Goodness. 200. Okay, and I pretty much will start at 200. I think I'll have enough. I might not even have enough at 200. I might need to go by 250. What did they go by? Of course, I don't have it. Okay, I would maybe go by 250 because you have to get up in value pretty quick. So 250. 500, 750, 1,000. Do I have enough? I think so. 1,250, 1,500, 1,750. Oh, goodness. I almost was there. Huh? What now? Go below 250? Yeah, that last one. Between 250. Oh, it's just halfway, so there's 250 in between, so 125. 120. I know, it's a big gap. All right, so let's look at the first one. The first year, how many people were there? We'll do this one together. How many people were there? 420. So year 1, go up to 420. That's going to be closer to 500, just somewhere in this range. Okay. Year 2, 500. Year 3, 650. So That's going to, halfway is 625, so it's going to be just a little bit above it. 900, year 4. So that's going to be just below 1,000. 1,100, year 5. Hey, what's happening to the festival?
It's increasing people.
Yeah, it's growing in popularity, right? They must be doing something right. They're attracting more people every year. 1,500 in year 6. Ooh, they got a big old jump. Right? And then 1,750 in year 7. And then year 8, they're like off the charts, actually, literally. All right, so we're somewhere up here in year 8. And that's okay. All right, so I'm going to try to go for the line of fit now. Now, one of the, well, let me ask you this. How many people did they have in year 0? 0, right? So this is a, we didn't call it a proportional relation. What do we call it in, I think it was section 4.3. Was it proportional relationship? Now that's going to bother me. Yes, proportional relationship, meaning when x is 0, y is 0. At 0 years, nobody was there. Okay? So that's where I'm going to start my line of fit. Okay? And then I'm going to draw it as best as I can. This might take me a couple attempts. All right, through the points. Okay, and again, the line of fit is just an estimate. It's just an estimate, so it's not going to pass through all the points. All right, it'll pass through some of them. Now, I can see my line of fit passed pretty clearly. You definitely need a ruler or a straight edge for sure. All right, look at mine. Which 2 points did mine pass like straight through? Yep, it passed through the 6, 1,500, and 7, 1,750. Okay, so 6, 1,500, and 7, and 1,750. All right, so go ahead and calculate your slope. Go ahead and calculate your slope. Okay, y2, 1,750, m equals 1,750. Minus 1,500 over 7 minus 6. Okay, so what's 1,750 minus 1,500? 250 over what? Over 1. All right, so can somebody give me the equation for the line of fit? What would be the equation for the line of fit? Y equals what? 250x plus 0, okay, because again, proportional relationship at 0 years, nobody came, okay? So just plus 0, or you don't even have to put plus 0. Your book had 270x. That's fine. That's fine. 250 is pretty close. Now, if you have 3 or some, number that's like not even close, that's not going to be good. So the y-intercept interpretation is pretty simple. Actually, we already said that. Could anybody kind of just repeat what we already said about our y-intercept, which is 0? After 0 years, nobody came. All right, that's almost like kind of a weird statement to make. Okay, so all right, so that's a y-intercept. What about the slope? The slope is clearly positive. Can anybody tell me how that number is relating x to y to interpret that slope? We would expect,
as time goes on, more people come.
More people do come. That's the overall just relationship, yes. But specifically with this number, what is this number telling me?
As each year comes 250 more people.
Yes. For every year, we would expect, again, it's not a guarantee, and you can definitely see some years jumped more than others. All right, so each year, we can expect attendance to increase how many? By 250 people. All right. Now, this could be helpful if I'm trying to make projections on, I'm like, man, I really want this event to be 5,000 people. Could I use this information to kind of project how many years down the road it would take to get to 5,000? That's what companies do when they say, we want to be $1 million company in 3 years. They're making these projections based on continuous and steady growth. That's slope. That's a rate. Okay, so in the business world, this is really important. Okay, all right, so we actually made it through both examples. All right, you guys did really well with that, and we'll keep working on it. That's it for 6.2.